In this problem, we're going to minimize distance or travel time. It says a farmer's house sits 5 miles due south of a river. You can see that in the diagram here. So the river runs right here, and the house is 5 miles from the river. The diagram below shows the path that the farmer takes from his house to the river every day in order to bring the water to a farm located 6 miles south from the river and 3 miles east of the farmer's house. So he's got a farm that is 6 miles from the river, okay? And it's also 3 miles in the X direction between the house and the farm. So his path is he walks here to the river, kind of at an angle, gets the water, brings the water back to the farm. It says, by choosing a different point P on the river to draw water, the farmer is able to walk different distances to do this task. Find the minimum distance possible that the farmer has to walk. Enter an exact answer or round to the nearest 100th of a mile. So we want to minimize this distance walked, which means to minimize that, we're going to have to find a distance. I'm going to call this x. Okay, so the x is we're going to call it the distance. Let's see, x is the distance. We're going to call this point Q, and then we'll call this point R. So x is the distance from point Q to point R, or point P, I mean. And then 3 minus x, because it's 3 miles here, from there to there, 3 minus x is going to represent, we're going to say that here, 3 minus x is distance from point P to R. Okay, so if I want to minimize his distance, I want to find, I'm going to call this D1 and D2. He walks a certain distance from house to the river and then back to the farm. I can find D1 and D2 by doing Pythagorean theorems and having x and 5 for D1 and 3 minus x and 6 for D2. So I can say that my distance is going to equal D1 plus D2. So total distance traveled, I'm going to say D equals D1 plus D2. All right. And actually I better say distance with an input of, let me write that, distance with an input of x is D1 plus D2. And then I'm going to find some values for D1. So D1 squared is going to equal 5 squared plus x squared. So then D1 is going to equal the root of 25 plus x squared. D2 is going to equal, D squared 2 is equal to 6 squared plus 3 minus x squared. Square root each side, we get D2 is equal to root of 36 plus 3 minus x squared. Okay, so we can substitute those in for D1 and D2 here and say that D of x is equal to root 25 plus x squared plus root 36. I might multiply this out. Is that going to make my life easier? I think so. So we're going to write this as equal to 3 minus x is to be root 36 plus 3 times 3 would be 9. Negative x times 3, we're going to do that twice, so that's negative 6x. And then we're going to take negative x times itself, so that would be plus x squared, which is going to give you root x squared minus 6x plus 45. So we're going to write that here, x squared minus 6x plus 45. Now we're going to take the derivative on each side. So we're going to do, say, the d prime of x is equal to, and when we take the derivative of root 25 plus x squared, first of all, we're going to have to do a chain rule here. So we're going to have 1/2. So this is all to the 1/2 power. So that'd be 1/2 25 plus x squared times the derivative of the inside, which is 25 plus x squared. And then that's going to be added with, if we do the derivative of this, we get 1/2 x squared minus 6x plus 45 times the derivative of the inside, which would be x squared minus 6x plus 45. So when we do this derivatives, we end up with d prime of x is equal to, the derivative of 25 plus x squared is just 2x. So I end up with 2x being multiplied times this 1/2. So I end up with x, parenthesis, 25 plus x squared. Derivative of this would be 2x minus 6. So I end up with plus 2x minus 6 over 2. So we're going to put over 2 times, oh, and I forgot to write these. These would be to the negative 1/2. So this is times x squared minus 6x plus 45 to the negative 1/2. So let's rewrite these. So that would be d prime of x is equal to x over root 25 plus x squared plus, this would be 2x minus 6 over 2 root x squared minus 6x plus 45. Okay, now I'm going to set this equal to 0. I'm going to kind of box this off here and say that, draw this around here. We're going to say 0 equals x over root 25 plus x squared plus, I'm going to factor a 2 out of this top piece, and that divides with this 2, so I end up with x minus 3 over root of x squared minus 6x plus 45. We're going to subtract this piece over, and we end up with negative x over root 25 plus x squared is equal to x minus 3 over root x squared minus 6x plus 45. All right, now we're going to go ahead and let's multiply. Let's cross multiply here. So this side is going to multiply to this. This side will multiply over here to the right side. And so we're going to end up with negative x root x squared minus 6x plus 45. And then that's going to equal x minus 3 root 25 plus x squared. And then we're going to square each side to get rid of the square roots. So when I square the left side, I'm going to end up with x squared times x squared minus 6x plus 45, because when you square the negative x, you get x squared. When you square this root, squaring a radical, it's going to cancel it out. So then we're going to, I'll write that here, square each side. So then you square this x minus 3, and you'll get x squared minus 6x plus 9 when you square the x minus 3. When you square the radical, you end up with 25 plus x squared. Okay. Let's see what we can do with this. Can we factor anything? So 45 factors to 9 and 5. Also 15 and 3. So that's not going to get us where we want to go. Let's distribute this and see what happens. So we end up with x to the 4th minus 6x cubed plus 45x squared. When we multiply on the right side, we're going to get x squared times x squared. Actually, just do the, x squared times x squared, x to the 4th. X squared times negative 6x will be negative 6x cubed. X squared times 9 will be plus 9x squared. And then 25 times x squared will be plus 25x squared. 25 times negative 6x will be negative 150x. And 25 times 9 will be 225. We can cancel now the x to the 4ths because they're on opposite sides of the equation, and the negative 6x cubes. And then I could, let's see, combine these x squareds together, and at the same time I'm going to subtract over this 45x squared. So I end up with 0 is equal to 9 plus 25 minus 45 negative 11x squared minus 150x plus 225. Now we're going to solve this quadratic formula. So to do that, I'm going to write this as x is equal to negative b plus minus root b squared minus 4ac all over 2 times a So then we're going to get x is equal to, plug in negative b, so that'd be negative 150 plus minus, let's see, negative 150 plus minus root negative 150 squared minus 4 times a, which is negative 11, times c, which is 225, all divided by 2 times negative 11. So we end up with x is equal to 150 over negative 22 plus, and then we're going to do, let's see, 150 squared minus 4 times negative 11 times 225. And we get plus 180 over negative 22, or x is equal to negative 150 over 22 minus 180 over negative 22. So let's see what we get here. 150 I get negative 15 for x here. And then this x is going to equal (15/11). Now, we got to go back and figure out, again, at the very beginning, we had some restrictions for what x could be. So x could not be more than 3, because the distance between Q and R, these 2 points where the house and the farm are, is 3 miles. So we have an x value that has to be between x is between 0 and 3. Well, negative 15 is not going to work, of course. So 15/11 is between 0 and 3. But we have to check the endpoints. So we need to go back to our original equation for d. So I'm going to go right back to this d of x value here. And I want to check, so I'm looking at this value here. I want to check d of 0, d of 15/11, and then I also want to check d of 3, the endpoints. Which one of these is going to minimize the walk for the farmer? I'm going to use a calculator to do all this work. So we're going to say second square root 25 plus x squared plus x squared minus 6x plus 45. And then we're going to plug in 0, store it as x. We got 11.7. So 11.7, this would be miles walked. Let's go ahead and do 15/11. $11.4 miles. And then now let's do the 3. We get 11.83. So you can see the minimal distance would be if the farmer were to walk 15/11, which 15 divided by 11 is about 1.36 miles in from point Q. So if we go to point Q, walked in 1.36 miles, so that farmer is walking to that point and then walking back to his farm ground. That'd be 11.4 miles, which is smaller than if he walks to point Q and then over, or to point R and then walks over and then walks down.